This is video 59 on MicroPython LVGL embedded solution. In this video, we improve our screen layout. By utilizing intrinsic LVGL features, we can dynamically size the components of a screen. We can add styles to make screen's interaction enjoyable. Please let us know in the comments if you like this example, or let us know if you have suggestions to improve it. For this effort, our testing includes the various small, medium, and large screens seen in previous videos. By chance, two displays utilize the Raspberry Pi Pico 2W USB board, and the third is using the 4.3-inch WaveShare large 800 by 480 display using an ESP32S3 USB module. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal is a MicroPython LVGL program with one example of displaying dynamic screen layout. We will run the program on any of our test rigs. We will review the hardware and design consideration of screen objects, discuss screen layout of the header, footer, and content objects. Then we will walk through the code. Finally, we add gesture actions to our program. The firmware and code files are at the GitHub site that is mentioned in the description and endnotes for this video. Now let's run a demo. We've started our test blue_display program on one of our test rigs. As you can see, there's a screen titled Homepage with a footer to the press the left or right button. The content is a label with this instruction. When we press the right button, we will see a screen titled Page 2. Let's do that. When we press the left button, we see a screen titled Page 1. We can press the green button. When we do, we'll see a message in the shell. The blue round button is labeled Bell. When we press it, the status indicator in the header turns white. This is to represent an alert. Even though we're using a button to activate this alert, we could do this within the program as well. We've also added gestures to the program. Now we can gesture right and Page 2 will be displayed. When we gesture to the left, Page 1 will be displayed again. And when we gesture up, the home page is redisplayed. That ends the demo. For embedded systems, one must study the display hardware as well as the screen design. Let's assume we want to make a program with 3 screen pages, and we want a design that allows us to easily navigate between the pages. Usually, a project assumes that it's using a specific display type, and so the screen is laid out to fit it. For our effort, however, we want the program to work easily across any of the 3 displays. For this video, then, we will stay focused on the navigation. We assume our content is simple and will fit easily on any of these displays. Our screen layout will be just a header, footer, and content. Let's discuss the header. We shall display a page title in the top portion of the screen across the width. The 30 is the height in pixels of the header object. Also, our page will optionally display the status. Embedded displays like ours usually have status icons in the top right of the screen. The LVGL PCT function automatically knows the resolution of the active screen. so it fits our header object to the screen width, and we align it to the top of the screen. We align the status icons to the top right of the screen. The footer needs to display 3 buttons, left, right, and home. We similarly fit it to the screen width and align it to the bottom. LVGL has a feature that allows us to fix the footer object to always be shown. We do this by creating the footer as a top layer object. Our content has to display between the header and the footer. We do this by initially defining it to the width and height of the display, and then add LVGL padding at the top and bottom. Then we can add content as LVGL Flex or LVGL Grid objects. But for this video, since we're keeping this simple, we will just align a button to the center of the display. That's the approach. So now let's look at the code. Our code consists of 2 files, my_styles, which is loaded into the flash of the microcontroller, and test_blue_display, which is run from Thony on the desktop. Let's look at my styles first. My styles consist of a set of colors, some default fonts. We've set a dark theme for our display, and it has a style for the button using those colors, the press state of the button, and it has a style for the header and footer. Notice that the style is setting all the pads to 0. That's very important to allow us to reuse the header footer style in multiple parts of the header or the footer. We also have a toggle style, and this is used to set the color of the alert, which looks like a bell. Okay, let's look at the test blue display program. It has the standard imports. Next, we've set up the screen, and this time we defined a top layer, which will be used by the footer later. We've set some variables. The status state is used by the alert. Here we've defined the page header. And here you can see where we've done that important bit where we've set the size 100% of the width of the display and only 30 pixels in height. We've also aligned the header to the top of the screen. Here we've applied the header footer style that we looked at earlier. Finally, we create the title and set it into the center of the header. Here's the screen status. You'll see that I've commented out 3 symbols. In other words, you could have 3 different alerts, but for the purposes of this demo, we're just going to use one of them. And this is the symbol character for a bell. Now, what we were using is a technique so that we could display all 3 if we wanted to. So we use the button matrix, and we're going to push the bell into the first button in the button matrix. We want to squeeze it into the right-hand corner, so we're going to set it to 30% of the header. And notice it's the same height as the rest of the header. Finally, we are going to align it to the top right of the screen. And here you see we've applied the header footer styles to the various parts of the status indicator. Now let's look at the page handler. So this is called whenever a button is, the footer button is pressed. This will then be the routine that changes the specific page that is displayed. Now we come to the screen footer. Here we come to the symbols again that we're going to use for the buttons in the screen footer. We have a symbol for previous, we have a symbol for home, and we have a symbol for next. It's represented by these codes. Again, we're going to use a button matrix. And here you see we've set it to the top layer. That will cause this footer object to always be displayed on the screen. We're going to set its size to 100% of the width and only 30 pixels in height. We then apply the symbols. And notice finally we align the footer object to the bottom middle of the screen. And finally, we apply the header footer styles just like we did for the header. It adheres the routine to add the event callback to the footer object. When we press the bell, we want to set the status. And so you see here, we just index into that button matrix, and then we set the state either on or off. And here's the callback for the status. It's going to call that routine to actually do the change in the button matrix. And we use this so that we pick the ID in the button matrix. You'll see where we define the ID when we define the buttons later. This is the button, either the green button or the blue button on page 1 and 2 that's in the center of the screen when it's the callback that we'll call when we press the button. Now we're going to define the content. We begin with the page home. So the content is going to call and create the page header. As you recall, the footer will always be displayed. So we're doing this so that we can dynamically change the title of the header. Next, we create the content. And you'll notice that if the content already exists, we will remove it and then garbage collect it. Here we've set, as we talked about in the design, the size of the content object to be 100% of the width and 100% of the height of the screen. Then we're going to pad the top of the content object and the bottom for the height of the header and the height of the footer. Finally, we do a move background, and that's so that the content doesn't over display the header. It gets pushed into the back. Finally, we have the actual content for the home page, and that's that message that we talked about that talks about the pressing of the specific buttons. Next, we have page 1. It's going to be very similar. The difference is we set a different label for page 1. We set up our content object the same as before. Here we've added the screen status. So now it's going to display the screen status. And so we have the button, in this case, is going to be green, that we've displayed in the center of the screen. You can see that. Here's where we set the green color. And we define the bell. And here's how we've set it up so that we can display, so we can activate either any of those status indicators. So for the bell object, if you press it, we're going to do this callback handler using a lambda. So if you recall, we can't put anything here because the C code expects a C pointer. So MicroPython gets around that by using the lambda to pass our data value. So 0 is the first item in the button matrix of the alerts of the status. If we passed 1, it would be the middle item, and if we passed 2, it would be the third item in the status of the status indicators. So if you wanted to create, if you wanted to add those other status indicators, you would simply create another object, display it wherever you want it on the display content, and then add a callback routine for a specific ID index. Okay, finally we have page 2. Page 2 is very similar to page 1, but it's just simpler. It just is going to set a button, and we have it create a callback to the same callback, so it just prints out one of these messages, click button, whatever. As you recall, we talked about the fact that we had gestures. So how did we add that? Well, gestures are utilizing the active in-dev device, which in this case is the touch screen. And then we use an in-dev function called getGesture_Direction. And this gets the numeric value of the particular gesture direction. So we use that gesture direction value to control whether we call the page home routine, the page 1, or the page 2 based on the type of, based on the direction of the gesture. And here we've added the gesture to the screen. We ran out the program by initially displaying the whole page when we start the program. In summary, in this video, we demonstrated one approach for dynamic screens and gestures. We discussed the screen objects and the LVGL functions. We walked through code examples. Hopefully, you learned more about designing screens that can work on any display. Please comment if you feel other changes are needed. I hope this video helps your MicroPython coding. Thank you for listening.